Lesson 5-3, you are going to use your know-it notes for this, although you might also want to have a piece of graph paper out for some of the things that we do today. You are going to use know-it notes page 67 and 68, so have those handy. And we'll probably break this into 2 lessons when we do it in class, but we're going to do the notes all at one time. That way you won't have any to do over the weekend. So let's get started. Maybe. Oh, there we go. Rate of change. And this is the first vocabulary word on page 67. You're going to have to write small to get these things in, but all of these things are really important. Rate of change is sort of a more general way of talking about slope. So rate of change is a ratio that compares the amount of change in the dependent variable, which is y, to the amount of change in the independent variable. Important other things to think about when you're thinking about rate of change. The rate of change is constant, meaning it's the same for any 2 points on a non-vertical line. And really, rate of change is just another way of saying the slope of the line. Go ahead and pause it if you need to take a little more time to get those 3 things written down. So, moving on to slope. That's the 4th vocabulary there. Slope describes how steep a line is. And really, we already talked about that with our Lucy linear, right? That's the number in front of x. That's what the slope, where the slope of the line is in the formula for the equation of a line. And it tells us how steep it is. So bigger slope, looking at the absolute value of the number, means it's steeper. Smaller slope, right? Especially those decimal numbers between 0 and 1 give us a flat line. And when we have a slope of 1, we have a 45-degree angle line. So remember, this is between 0 and 1. Okay? And bigger slope would be slope greater than 1. The variable we use for slope is m. I looked it up last year trying to figure out why there's no consensus about why m is used. I like to think it's m for mountain because I can ski down the slope of the mountain. But that's not the real reason. And there's so many reasons there really isn't a real reason. Oh, my board is being kind of finicky today. The slope of a line, and you are going to want to write this, either keep going with slope or fill it in next to where you have the lines for rise and run. The slope of a line is the ratio of the rise, which is the change in y, to the run, which is the change in x between any 2 points on the line. So it doesn't matter what 2 points you choose, the rise and the run will always end up having the same ratio after you simplify it. So m equals rise over run. Definitely write that down somewhere. Put a big box around it. Put a big star next to it. Right? This is super important. Memorize that. Slope equals rise over run. Rise is the change in the y value between your 2 points. Run is the change in your x values. Actually, go ahead and flip to page 68, and there's a spot for this up at the top of the page on 68. You're going to sketch 4 coordinate planes. Okay? Just basic, pluses you can see like I have here. You're going to need 4 of them. Positive slopes, always the line goes up to the right. Always, always, always. Okay? Negative slope, the line goes up to the left. Always, always, always. So the moment you see the line on the graph, you should be able to tell yourself, all right, I should get a negative slope. Okay, I should get a positive slope. That is something that you want to have deeply in your head. For the other 2, horizontal lines, not surprisingly, have no slope. They're flat, no slope. Okay. And those come from lines that are just y equals a number. Like this looks like maybe it would be y equals 2. Okay. It has a slope of 0. Vertical lines have an undefined slope. because we can't divide by 0, and if you try to, when we use the formula and we try to subtract to get the numbers in our formula, we end up with something over 0. So you can write no slope when you're asked the slope of a vertical line, and the equation of this line is something, on this one it looks like maybe it would be x equals 3. Okay, but it has no slope. A good skill to have is to be able to figure out the slope from a graph. Okay. In order to do that, and they are asking you to fill this in, continuing down on page 68, okay, is that you're going to pick 2 places on the graph where the line crosses at obvious whole number spots. On this graph, which you should sketch or get out a piece of graph paper and do more exactly on graph paper. I'll give you a choice on this one. Okay. Graph paper would be better though. Okay. 2 obvious places to me look like right here, 1, 2. And another really obvious place looks like right here, -3, -1. And then you're going to draw a triangle. The line is always going to be the hypotenuse of the triangle. You draw the 2 legs. It always makes a right triangle. And now we're going to count the rise and we're going to count the run. We're counting spaces, not lines. Count the boxes or spaces. So the rise is 1, 2, 3. The run is 1, 2, 3, 4. So my slope would be 3/4. Okay, so make sure you draw that triangle. Really helpful. It's not babyish. It's not the little kid way of doing things. This is how you do it. Draw the triangle. Count the boxes. This comes in handy. You can come back to this over and over again. Let's do one more. So on your graph paper, if you've got it, if not, sketching, but I don't like that as well, go ahead and pause the video and draw the graph and see if you can pick out 2 good points, draw your triangle, and count the slope. Now that you're back, here's what I would probably pick. I would definitely pick this point, which is at -1, 3. And another really good point on my graph looks like it's here at 2, -2. And I'm going to draw my triangle. Okay. And you don't have to put the right angle corner in there. I'm just reminding you it is a right triangle. And now I'm going to count. My rise is 1, 2, 3, 4, 5. And my run is 1, 2, 3. But I'm noticing that my line is going up to the left instead of up to the right, so it's going to be negative. Okay. If you count left and up, it's negative. Or if you think of counting down and to the right, it's negative. Right? One direction or the other, thinking on the number line, you were going down. Okay. So, or you can just memorize. Lines going up to the left, it's got to be negative. We'll do more practice of this in class because I think this is a really important skill. Woo! Hold on. Okay. A few little things that are good to know, and you probably just want to jot these down somewhere. There's space, and we'll get to the rest, don't worry, from the equations and all that other good stuff and the formula. You're going to leave slope as a fraction or an improper fraction, but simplify it. Don't turn it into a mixed number. It's not handy. Okay? Just leave it as a fraction. Don't turn it into a decimal. It's not handy. Just leave it as a fraction. When you count right and up, you've got a positive slope. Count left and up, or right and down, that means you have a negative slope. If you need more time to write those things down, go ahead and pause the video. We're going to move on to the formula for calculating slope when you don't have a graph or you don't want to graph it. One too far. There we go. The formula, and there's a nice blue box for this back on page 67, along with a nice little picture. In general, we can name points just x and y, but when we have more than one of them, we're just going to call it x1 and y1 for the coordinates of this first point. So here we have x1, y1. And my other point, in general, I'm just going to call it x2, y2. And if that's the case, then to find how much the line goes up, I need to take the smaller number away from the bigger number for the y coordinates only. Because right here, all I'm concerned about is y coordinates, right? If I'm looking for how far apart they are vertically. So that is y2 minus y1. That's the rise of the line. I subtract the y coordinate, the smaller y coordinate from the bigger one, or the lower one from the higher one. For the run, I'm going to measure how long the line is by subtracting x1 from x2. So I'm trying to find out how far is it from here to here. If this was, -2 and this is 5, then they're 7 apart. It's a subtraction problem. And then we just plug that in to what we already knew, which is that slope equals rise over run. And we get our slope formula. You need to memorize this. So write it down in that blue box. Okay, m equals y2 minus y1 over x2 minus x1. And highlight it, box it, star it, something, right? Write yourself a note. Memorize. I need to know this. Once you have the formula, which you already have now, and you memorize it, which you're going to do ASAP, now it's just a plug and chug, right? I give you 2 ordered pairs, you plug them in. The only hard part is keeping the numbers in order. And really, how hard is it to keep numbers in order? So let's start with a really basic one. This you can just keep going right there on page 67. Find the slope of the line containing the points 1, 1, and 2, 3. You could graph it, and then you could count it, but that's slow, right? I don't have the graph already. Let's just calculate it. So we know the formula is y2 minus y1 over x2 minus x1. And so I just plug it in. Okay? Let's call this one x1 and y1 because it's first, and this one x2 and y2 because it's second. And so y2 is 3, y1 is 1, x2 is 2, x1 is 1, 3 minus 1 is 2, 2 minus 1 is 1. So the slope of the line is 2 over 1, or just 2. Now you try. Slope of the line through the points 0, -3 and -4, 8. Pause the video. Calculate it. Now you're back. Now my guess is that you used 0, 3 as x1, y1, and that you used -4, 8 as x2, y2. I'm going to do it the other way. And let's see if we get the same answer. Okay. So I'm going to say that these are 2 instead. Okay, so I'm going to change it. And I'm going to call these ones x1 and y1. So I do x2. Oops. How about I do y2? Undo, quick. Okay. How about y2? There we go. Minus y1, which is 8, over x2 minus x1, which is -4. And I do a little zip zapping. There we go. Plus -8 plus +4. And I get m equals -11 fourths. If you did it the other way, you probably got 11 over -4. And guess what? That's the same thing. So does it matter which point you use as x1, y1? No, it doesn't matter. Get the same answer either way. Right? If you did it the other way, you had 8 minus -3 over 4 minus 0. And you had 11. Where's the negative coming from? I lost it. Oh, -4 minus 0. There we go. And that gave you 11 over negative 4. Same thing. Doesn't matter. Quick here. Horizontal lines. I want you to see why the slope is 0. Think about it. y2 minus y1, right? Here's y2. Here's y1. 2 minus 2 over negative 2 minus 2 is 0 over negative 4. That's 0, right? Horizontal lines always have a slope of 0. You don't need to calculate it. If you see two lines with the same y coordinate, they have a slope of 0. 2 points with the same y coordinate. Vertical line, right? Notice now they have the same x coordinate, and when I go to do my my slope, I would get negative 3 minus 2 over 4 minus 4, and I end up with negative 5 over 0. No dividing by 0, so you would either write undefined or you can write no slope. Not 0. 0 is a number. 0 is the slope of a horizontal line, but no slope. You need more time to write those down. Write down there on 67 somewhere. Go ahead and pause it. We're going to do one last thing and then we're done. Real life situations. Okay, the slope of a graph often represents the rate at which something is happening. Remember how we've calculated unit rates? Unit rate really is the slope. If we graph something that has a unit rate, that's what the slope is. So let's take a quick look here. And then we'll do another one of these in class. Cost of electricity for a refrigerator. We've got our data here. We're going to graph it. You're going to graph it too. So grab that graph paper back. Sketch it if you don't have any. Graph paper is better. 5, 15, 10, 30, 15, 45. And its cost, we're looking at the time in months, and we could break that down. So let's go ahead and we'll draw the line. You should use a ruler, but I'm not going to because I forgot. Okay. What is the slope of the line? Well, to calculate the slope of the line, I just need the difference in y over the difference in x between any 2 points. Now be careful if you count boxes. Remember, you're not counting by ones here, right? Every box here is 2.5. So like if you're counting, this is 5 in the run and 15 in the rise. So be careful. You can also just do it from here. The difference in y values, 15 minus 0. The difference in x values, 5 minus 0. So the slope of the line is 3. Okay, so that answers the first question. What does it mean? Well, that means, right, for every 1, right, I go up 3. Over 1, up 3. Over 1, up 3, which means it costs $3 per month. That's what the slope is actually telling me in this case. It's telling me the rate of change. The unit rate for having my refrigerator is $3 per 1 month. Some of you are saying, well, yeah, I could just do that by dividing. And in this problem, you could. Not always, but in this one, you definitely could. That's it, ladies and gentlemen. More about slope when you come to class. Signing off.